The Philippine Trench is the third deepest place on Earth at 34,580 feet deep. But unlike the famous Mariana Trench, this underwater abyss sits on one of the most active fault lines on the planet and could trigger the next mega-earthquake. While everyone focuses on the Mariana Trench, there's a deeper, more dangerous abyss lurking beneath the Philippines that produces some of Earth's most powerful earthquakes and devastating tsunamis. The Philippine Trench has generated multiple magnitude 8+ earthquakes and sits directly beneath one of the world's most populated regions. Scientists call it a sleeping giant that's overdue for catastrophic awakening. At 34,580 feet deep, the Philippine Trench has been explored less than the surface of Mars. What scientists have found in its crushing depths challenges everything we know about life's limits. Maximum depth, 34,580 feet, 10,540 meters at Galathea depth. Global ranking, third deepest ocean trench on Earth. Location, east of Philippines in western Pacific Ocean. Length, 870 miles, 1,400 kilometers. Width, 40 miles, 65 kilometers at widest point. Age, approximately 10 million years old. Alternative names, Philippine Deep Mindanao Trench. Formation, created by Philippine sea plate subducting under Eurasian plate. Subduction rate, 9 centimeters per year convergence. Tectonic setting, part of complex Pacific Ring of Fire system. Associated features, Philippine fault system, Mindanao volcanic arc, crustal structure, oceanic crust diving beneath continental margin, magma generation, subducting plate creates volcanic activity above. Earthquake frequency, regular magnitude 6, 8 earthquakes. Major historical quakes 1918, Celebes Sea 8.3, 1976, Moro Gulf 8.1, tsunami generation, major source of Pacific tsunamis, fault systems, multiple interconnected fault networks, seismic gaps, areas overdue for major earthquake activity, deep earthquakes. Some earthquakes occur 400+ miles underground. Recent major seismic events. 2019 Mindanao. Series of magnitude 6+ earthquakes. 2012 Samar, magnitude 7.6 earthquake and tsunami. 2017 Surigao, magnitude 6.7 earthquake causing significant damage. Ongoing activity. Continuous smaller earthquakes indicate active system. Monitoring concerns. Increasing frequency of moderate earthquakes. Scientific attention. Growing focus on seismic hazard assessment. Water pressure, 1,086 times greater than sea level pressure. Temperature, near freezing at 1 to 4 degrees Celsius, 34 to 39 degrees Fahrenheit. Light, penetration, complete darkness below 3,000 feet. Oxygen levels, extremely low dissolved oxygen. Chemical environment, high salinity, unique chemical composition. Current systems, complex deep water circulation patterns. Pressure-adapted species, creatures surviving extreme pressure conditions, amphipods, specialized deep-sea crustaceans, bacterial communities, chemosynthetic organisms thriving without sunlight, endemic species, creatures found nowhere else on Earth, evolutionary adaptations, unique adaptations to extreme depth, biodiversity, hotspot, surprisingly rich ecosystem despite harsh conditions. First measurements, 1951 by Danish research vessel Galathea. Deep-sea submersibles, limited manned explorations due to extreme depth. Modern surveys, advanced sonar mapping and robotic exploration. Research challenges, extreme conditions limit scientific access. International cooperation, multiple countries involved in research. Ongoing studies, continuous monitoring and exploration efforts. Versus Mariana Trench, 1,125 feet, 343 meters, shallower than Challenger Deep. Versus Tonga Trench, 1,122 feet, 342 meters, shallower than Horizon Deep. Versus Japan Trench, 2,300 feet, 700 meters deeper. Seismic activity, more seismically active than Mariana or Tonga trenches. Population risk affects more people due to nearby population centers. Shipping lanes. Major international shipping routes pass nearby. Military significance, strategic importance in Western Pacific, resource exploration, potential for deep-sea mining operations, communication cables, undersea cables cross trench region, territorial waters, complex international boundary considerations, economic zones, affects exclusive economic zones of multiple nations. Historical tsunamis, generated multiple devastating tsunamis, at-risk populations, over 100 million people in potential impact zones, wave propagation, tsunamis can cross Pacific in hours, warning systems, Pacific tsunami, warning system monitors activity, coastal infrastructure, ports, cities and infrastructure at risk, international impact, tsunamis affect multiple Pacific Rim countries. Marine habitats, creates unique deep-sea environments, nutrient cycling, affects ocean chemistry and nutrient distribution, current systems, influences regional ocean circulation, carbon storage, deep trench acts as carbon sink, biodiversity role provides habitat for specialized organisms, climate influence affects regional and global climate patterns. Autonomous vehicles, ROVs and AUVs for deep exploration. Pressure-resistant equipment, specialized instruments for extreme depths. Seismic monitoring, networks of underwater earthquake sensors, sonar mapping, high-resolution bathymetric surveys, sample collection, deep-sea sediment and biological sampling, satellite observation, space-based monitoring of surface effects. Polymetallic nodules, potential source of rare earth elements, hydrothermal vents, possible mineral deposits at depth. Sediment resources, deep-sea sediments contain valuable materials. Mining challenges, extreme depth makes extraction extremely difficult. Environmental concerns, mining could destroy unique ecosystems. Economic potential, estimated billions in potential mineral wealth. Sea level. Effects, deep trenches respond to changing ocean levels. Temperature changes, global warming affects deep water temperatures. Ocean acidification, chemical changes impact trench ecosystems. Current modifications, climate change alters deep ocean circulation. Ice sheet interactions, melting ice affects tectonic stress patterns, long-term monitoring. Climate studies require decades of data. Local knowledge, Filipino fishing communities aware of deep waters. Navigation history, ancient Polynesian navigators understood deep areas. Modern discovery, Western science discovered trench in 20th century. National pride, source of scientific interest for Philippines. International cooperation, symbol of shared ocean research. Educational value, important for marine science education. Earthquake prediction, improving seismic hazard forecasting, ecosystem studies, understanding unique deep-sea life, climate research, role in global ocean circulation, resource assessment, evaluating mining potential and environmental impact, technology, development, advancing deep-sea exploration capabilities, international collaboration, coordinating multinational research efforts. Deepest points, full extent of maximum depths unclear. Biological diversity, many species likely remain undiscovered. Geological processes, complex tectonic interactions not fully understood. Earthquake timing, inability to predict major earthquake timing. Resource extent, unknown mineral and biological resources. Long-term stability, how trench will change over geological time. The Philippine Trench remains one of Earth's most dangerous and least understood features. A sleeping giant in the depths, waiting to reshape our understanding of the planet's power.